Alright, today's video is on the metric system. I just wanted to start off with a graphic representing the countries that use the metric system versus the countries that don't use the metric system. We are a non-metric system country, so you'll see the United States in red. You will also see Liberia in red, and you'll see Burma in red. Now, we are so out of date that, even Burma doesn't even call themselves Burma anymore. They're in Myanmar. But we're out of date. Everything we do scientifically, and a lot of times even in the automotive industry, they're moving towards the metric. You don't want to be caught in between. So we need to be progressing towards the metric system, and understanding it is definitely going to help. It's much easier to use. Everything is multiplied by 10, divide by 10, so that definitely makes it easier. Alright, a big thing that we're going to be dealing with in the metric system is obviously we need to have bases. We need to have things that we can work with in the metric system. So we're going to do a lot of measuring, and that's what our lab's going to be about tomorrow. So let's take a look at some things we might be using in chemistry. The ones that we're probably going to be spending the most time with are going to be mass, and then if you go down to the bottom where it says amount of substance, we deal a lot with those. We also deal with temperature. We will deal with length somewhat. Mostly we'll deal with like electric current when in chemistry or in physics. But we could deal with all of these in chemistry if you really delved into it and got into an area of chemistry that did cover it. But length, the basic unit is going to be meter. Now that happens to be what we consider to be the base unit. Its symbol is just M. Mass. Mass is going to be the base unit of kilogram. Notice it's got a prefix on it. Okay, so the base unit, now these are the SI units, the System International units. So kilogram is going to be the base unit, so it's kg. So when we talk about SI units, kg will be a unit, even though in chemistry we use just gram, which is the actual base unit on our scale, which we'll see here in just a second. Okay, time is second. We know how to work with seconds, that's easy. So it's S. Electric current is an ampere, a big A. Temperature. Temperature is one that we tend to think that when we're going into the metric system, it's automatically going to go to Celsius. That's not the case. We have one that actually has a 0, which is actually 0, and that's Kelvin, and that's represented with the K. There's no degrees Kelvin. Kelvin is just K. Celsius, it's kind of on the same scale. It just has a different starting point. Okay, lights, that's candela, and then the amount of substance is a mole. You'll notice that mole, they have kindly abbreviated it MOL. They've taken a 4-letter word and made it a 3. They're very kind. Now this is the metric system chart. So basically it's going to start with kilo, and we're going to go all the way to milli. This is the one that you've probably seen throughout middle school. You kind of know what's going on with this. Now we will be working above this scale, and we'll also be working below this scale. As soon as we're done with this little part right here, I'm going to go ahead and we're going to work some stuff out on the board where I kind of show you how far down we go and how far up we go. But this kind of gives us the base idea of what's going on. You'll notice that the middle unit is the base unit. Anything that doesn't have a prefix is the base unit. So meter, there's no prefix, there's nothing in front of it. Gram, there's nothing in front of it. Liter, there is nothing in front of it. Heck, it doesn't really matter. I could come up with made-up units. I could call it a flarg. If there is no prefix in front of it, it will be your base unit. Okay, so we'll use that base unit. I'm about ready to run out of the screen here, it looks like. But kilo is up there. Kilo is 1,000 of the units. So kilometer is 1,000 meters. Hecto is 100 of the units. Deca is 10 of the units. So think of decade. Deci, also think of decade, but now we're on the small end. Deci is smaller, or it's not as harsh as deca, so it's smaller, it's softer. So it's 0.1 units. Centi, so think century. Those are 0.01 units. So it takes 100 of them to make up your base unit. And then milli is 0.001 units, or it's to the thousandth. So it takes 1,000 of them to make up a base unit. You'll notice that on this graph they've also got where you can have the decimal points. Okay, move the decimal to one direction, move it in the other direction. Any way you look at it, you will be set to move. All right, here's the extended version that I was kind of talking about just a second ago. You can see the base. Okay, we have the base here. It's underlined. But kind of the base thing that we kind of probably should already know by now, the KHD, DCM. This is probably something you want to write on your paper just about every time you're working these problems. You can use a mnemonic device to come up with whatever you want to remember that by. Mine's a little bit crude, but it's Kane has diarrhea but doesn't care much. Okay, it helps me remember it. You can use whatever you want to use. I know a lot of you have King Henry died by drinking chocolate milk. That's fine. I don't care. Whatever's going to get you to remember it, that's what's important. So if this is our base unit, this is our 0, this is our 10th, 100th, 1,000th. We have these ones that are way down here. Now I've put blanks in there. Those blanks are 10,000th, 100,000th. Who cares? Okay, what we're worried about is the next one. Okay, the millionth. It makes sense for us to want to know what the thousandth is. It makes sense for us to know what the millionth is. It makes sense for us to know what the billionth is. So that's why those are in there versus 10 millionth, 100 millionth. Who cares? Okay, so what we're going to call those, we actually have to give them names. This guy right here, I know it's hard to see, so I'm going to draw it a little bit bigger. Okay, it literally looks kind of like a U, but has a big tail in front. That's the Greek letter mu. M-U. Okay, that is the symbol for micro. Okay, so that's a micro. So if I want to do meters, a micrometer is a millionth of a meter. Really, really small. Okay, so if you are obviously like a microbiologist, you're probably going to deal with those things. If you are a chemist, you're going to deal with those. If you are in physics, okay, I've had a student just came back and said, hey, I deal a lot on this end down here. Okay, I don't deal a lot with the big stuff. Everything down here is what I deal with, the micro, the nano. Okay, so let's talk about nano. Nano's the next guy down there. Okay, so if this is millionth, this is billionth. So that's N, which isn't just N, it's the Greek letter nu. Sounds like I've got a cold, but NU. Okay, NU is to the billionth. And that's what we call it. We call it nano. Okay, so you hear them talking about nanotechnology. Nanotechnology is talking about things that are really, really small. So in this case, we're talking about things that are to the billionth. Uber small. Okay, super, super duper small. When we talk about light waves, we talk about nanometers. Small. Okay, go in the other end. Okay, so we have 10 of them, 100 of them, 1,000, kilo. Okay, we see that a lot. Blank, we don't care about 10,000, we don't care about 100,000. Now, mega though, that's a million. Okay, we start seeing these a lot more when we talk about computers. We talk about memory. Okay, it used to be kilobytes. We had a kilobyte of memory. That used to be a lot of memory. Now you guys are like kilobytes, nothing. Okay, even a megabyte for you guys. You know, you have little flash drives that are, you know, megabytes, nothing. Okay, you're going to use that up in no time flat. Gigs. Okay, same thing. This is giga, so this is billionth. Okay, so if I have a gigabyte, I literally have a billion bytes of storage. Okay, and I had blank, blank, and now we see this a lot when we're talking about external hard drives. When we're talking about, probably you'll see flash drives even have this now. Tera. Okay, probably not quite yet, but Tera will be there. You see terabytes of storage, and that's really, really commonplace. So getting big, we won't use this a lot in chemistry, but it's important still to know the principles of how we're getting there and where we're moving from one to the other. Okay? What I'm going to do is make sure you get your notes done, make sure you get your summary done. Tomorrow you have your measurement lab to get started. Okay? This measurement lab takes several days to get done. So you need to make sure you bring the focus, make sure you're ready to work. You're going to ask questions, but at the same time, you're going to have to work on your own in different groups. Okay, not everybody's going to be working on the same stuff, so make sure you're prepared to change direction, move quickly on a moment's notice, and get stuff done. Okay, so that's the end of the metric system as far as what I want to get done. Tomorrow night you'll have a video on significant figures. Okay, sig figs will definitely be coming to factor into your lab. So when you get a little frustrated saying, "Hey, Mr. Brewer, I didn't realize I had to go back and change these things," it's not a big change, but it's something that we do need to fix. Okay, so good luck on your lab tomorrow. We'll see you.